Hello my dear students, how are you? Fine? Okay, now in today's lecture we will discuss Clemmensen reduction reactions. इसके पहले के लेक्चर में हमने पढ़ा Wolff-Kishner reduction reaction with their mechanism and application. Now in today's lecture we will study Clemmensen reduction reactions. उसके बाद दोनों में क्या डिफरेंस आता है? What will the basic difference in Clemmensen and Wolff-Kishner and how different product will be obtained by using Clemmensen and Wolff-Kishner reduction reaction. This we will discuss at the end of lecture. So now let's start. Purpose of this Clemmensen reduction reaction. Clemmensen reduction reaction is used to convert carbonyl group, carbon having a double bond with oxygen. One is sigma and second is pi. It may be aldehyde or ketone. So aldehyde or ketone can be reduced into methylene group by using Clemmensen reduction reactions. So carbonyl group will be converted into methylene group, and as a result from aldehyde or ketone we will obtain hydrocarbon. अब reagent zinc amalgam, mixture of zinc with mercury. It's a one type of alloy. So it is zinc amalgam and concentrated HCl we are using as a reagent. So यदि आपको reagent में concentrated HCl है और zinc mercury के साथ दिया गया, then it's a Clemmensen reduction reaction. Purpose to convert carbonyl group into methylene group. It is applicable to aldehyde as well as ketone. So converted into corresponding hydrocarbon. तो क्वेश्चन होगा कि किस तरह से रिएक्शन होगी. जिंक मेटल है, किस तरह से कन्वर्ट करेगी. Then let's we discuss about the mechanism. मैकेनिज्म की हेल्प से आपको समझ में आ जाएगा किस तरह से रिएक्शन होती है. तो चलो स्टार्ट करते हैं. नाउ कार्बोनिल ग्रुप, कार्बन हैविंग ए डबल बॉन्ड विद दिस ऑक्सीजन. Now oxygen having a partially negative charge, carbon having a partially positive charge, one sigma and second pi bond. Now we have used a zinc metal. So zinc है उसकी oxidation होगी. It's a very easily undergo oxidation reaction and it gives a 2 electron. So zinc will convert it into Zn plus 2 and it gives 2 electron. अब oxygen की electronegativity ज्यादा है, then this bond will break, it electron transfer on oxygen. यदि इलेक्ट्रॉन ऑक्सीजन पर ट्रांसफर हो गए, then oxygen will get a 100% negative charge and कार्बन के पास मिलेगा positive charge. So this zinc give electron to this carbon. So now this carbon have also electron. उसके पास एक कम था, दो आ गए, so one more. So in short, zinc will approach this bond. This bond will break, electron transfer on oxygen. Zinc have given 2 electron to carbon. So now carbon and oxygen both having a negative charge. Now we have used HCl, hydrochloric acid. So in 2 molecule of hydrochloric acid we will get this 2H plus and Cl minus. So hydrochloric acid will give H plus to both carbon and oxygen. So this carbon as well as oxygen give electron pair to hydrogen. And as a result, we will get this CH and here OH. Carbon have also get hydrogen and oxygen have also get hydrogen. And in our reaction mixture, we have a Zn2 plus and Cl. So this Zn and Cl converted into zinc chloride, ZnCl2. So zinc plus 2 combined with this 2 chlorine gives us ZnCl2. Now once again our reaction medium is acidic. So in acidic medium once again hydrochloric acid having a H plus and Cl minus. So this oxygen give electron pair to this hydrogen, and as a result in acidic medium we will get this type of structure. Now this carbon having a hydrogen and this oxygen joined with a 2 hydrogen and positive charge. So here this carbon oxygen bond will break. When this carbon oxygen bond will break, water molecule will eliminate and bond electron taken by oxygen. So as a result we have a Here once again carbon with hydrogen with a positive charge, and H2O as a byproduct. Then once again zinc will give electron pair to this carbon atom. So this 2 electron pair will be given to this carbon in the presence of zinc. And once again this carbon converted into negatively charged carbon anion. And in our reaction mixture we have a water. So protonation occur again. When this protonation occur, carbon give electron pair to this hydrogen. Or in our reaction mixture we can say here hydrochloric acid is available. So carbon give electron pair to this hydrogen, and as a result, now this carbon having a 2 hydrogen means methylene group, and we have a Cl minus. So whatever Cl minus we have obtained, one Cl minus we have obtained at here. Similarly, another Cl minus is present in reaction mixtures at here. So this once again both Cl will convert it into ZnCl2. And during this reaction, what happened? This carbonyl group C double bond O converted into methylene group. So here, zinc is working as a catalyst. And by using this reaction, same as no any change, just like Wolff-Kishner reduction reaction, carbonyl group converted into methylene group. तो चलो उसके एग्जांपल स्टडी कर लेते हैं. Suppose I have benzaldehyde, benzene ring C double bond OH. Then this is nothing but benzaldehyde. Now this benzaldehyde on reduction reaction क्या मिलेगा? By using this Clemmensen reduction reaction, CR I have written Clemmensen reduction reaction, reagent zinc amalgam with concentrated HCl, carbonyl group converted into methylene group, and as a result we will get this structure benzene ring with CH3, and this product is nothing but a toluene. So by reduction of benzaldehyde we have obtained toluene means methylbenzene. Similarly, suppose I have acetophenone. Acetophenone structure you are knowing very well. Now I have written little different way. Benzene ring C double bond O CH3. This structure is acetophenone. चलो इसका क्लेमेंसन रिडक्शन रिएक्शन होगा, क्या प्रोडक्ट मिलेगी? यदि आपने वुल्फ-किश्नर रिडक्शन रिएक्शन पढ़ लिया है, then once again same product we are getting in different way by using reagent. C double bond O converted into CH2. So benzene ring and CH2 CH3. Then this product is nothing but ethyl benzene. So हमें ethyl benzene मिलता है. We can write lots of another examples. Suppose I have given you this type of dot structure. Suppose I have this type of structure. चलो इसका नेम लिख लेते हैं. कार्बन एटम 1, 2, 3, 4 and 5. 5 carbon. Carbonyl group, so it's a ketone. Ketone group is present on second carbon, so it's a pent-2-on. We can write name of this structure pent-2-on. Now in this pent-2-on, by using this Clemmensen reduction reaction, we can convert this product into carbonyl group converted into methylene group. So as a result, we will get this type of structure 1, 2, 3, 4 and 5 carbon. So pent-2-on will convert it into pentane. So by using this, it is observed that carbonyl group converted into corresponding methylene, means aldehyde or ketone can be converted into hydrocarbon group. लेकिन अभी हमें डिटेल से पढ़ना है. What is the basic difference in product in some specific case when we are using Wolff-Kishner or reduction reactions? तो पहले इसका स्क्रीनशॉट ले लीजिए, then we go for next part. Let's start. What will be the different product in case of Clemmensen and Wolff-Kishner reduction reactions? So one important note, due to the basic medium, hydroxyl group will not affected by Wolff-Kishner reduction reactions. but it is affected by Clemmensen reduction reaction. यानी Wolff-Kishner reduction reaction में medium is basic, so it is not effect on a product. But in Clemmensen reduction reaction, due to acidic medium, it will affect on a product. Now here we have 2-hydroxybenzaldehyde. Wolff-Kishner reduction reaction लेंगे, then this carbonyl group will convert it into methylene group. So इसमें product मिलेगी CH3. So here we get this type of product. Benzene ring, here CH3 and here OH. So उसका name हम लिख सकते हैं 2-hydroxy. We can write name 2-hydroxy toluene. तो यहाँ में 2-hydroxy toluene मिलेगा. But in Clemmensen reduction reaction, ये group का reduction तो होगा. It will convert it into methylene group. But due to the acidic medium, this H plus ion will approach to hydroxyl group. इसमें basic medium में तो hydroxyl group will not affect on this hydroxyl group, but here this oxygen give electron pair to H, it is converted into H2O and it will remove. This hydroxyl group will remove. When hydroxyl group will remove, bond electron taken by oxygen, so carbon having a positive charge. So this chloro group will attach with this carbon, and when chloro group attach with this carbon, we will get this structure. So due to this acidic medium, this OH will remove in the form of H2O. First protonation occur, it converted into H2. Here positive charge on this car part. This bond break, electron taken by oxygen. So it will once again remove, and here this carbon will get a positive charge. With this positively charged carbon, chlorine group attach, and as a result we get this 2-chlorotoluene. So देखिए reduction reaction purpose starting में same थे, लेकिन due to the difference in medium, here we are getting as-it-is product, but here substitution of hydroxyl group occur, and as a result chloro group will enter. So if Wolff-Kishner reduction reaction due to basic medium, it will not affect, but acidic medium will affect. तो एग्जाम में पूछा जा चुका है, what will be the product? You have to predict now. Try to give answer by yourself. Here 3-hydroxy cyclohexanone, तो इसका Clemmensen reduction reaction हो या Wolff-Kishner reduction reactions. Carbonyl group will convert into methylene group. ये hydroxyl group Wolff-Kishner reduction reaction में affect नहीं होगा, then we get product this cyclohexane and with hydroxyl group. So we can write that cyclohexane or 1-hydroxy cyclohexane will be obtained. This is the product 1-hydroxy cyclohexane. लेकिन Clemmensen reduction reaction में change हो जाएगा. This carbonyl group will convert it into methylene group. It will be right, but this hydroxyl group will affected by this acidic medium. We have studied that here H plus Cl minus hydroxyl group will join, carbon oxygen bond will break, hydroxyl group will join with H, remove in the form of H2O, and chlorine will attack on this carbon. So as a result, our product will be different. We get a 1-chlorocyclohexane. So difference is the main thing. Hydroxyl group hai, it is affected by Clemmensen reduction reaction due to acidic medium. Same thing will occur at here. Suppose we have used Clemmensen reduction reaction, then this group will convert it, and similarly nitro group will remove, and in place of nitro group, chloro group will come. So we get a 1-chlorocyclohexane. But in a case of Wolff-Kishner reduction reaction, it will not affected. So as a result, here we get this product 1-nitrocyclohexane. So it will not affect on this nitro group. Carbonyl group is only reduced and converted into this. So this is the basic difference between Wolff-Kishner and Clemmensen reduction reactions. ये आपको एग्जाम में पूछा जाता है. All the best. See you in next lecture.